Hey guys, Dr. Brown here. In an earlier video, we integrated tangent inverse x over 2 divided by 4 plus x squared dx, and we ended up with 1/4 tangent inverse x over 2 parentheses squared plus c. We're going to take the derivative of that in just a moment, okay? And that's what this video is all about, the derivative of this to see if that answer is correct. Now, you know, there's two rules here we're going to use. One is a constant multiple rule, and the other one is the chain rule. Okay, for constant multiple, if I have some constant times, let's say that function, and I'm trying to take the derivative of that with respect to x of all of this, I can move that constant to the outside and then take the derivative with respect to x of just x squared. So I'd have a times 2x. So 2ax would be my derivative. So I'm going to do that here in just a moment. Now the chain rule, if I have some function, an outside function and an inside function, and I'm trying to take the derivative of that, which in our case we have a squared term. It's the outside function. So I'm going to take the derivative with in this case 2 times the inside function, and then 2 minus 1, which is 1. So I decrease that exponent by 1, and then take the derivative. So now it's times the derivative of what's on the inside. So that's the simple analysis of the chain rule. Derivative of the outside function times the derivative of the inside function. Okay, so that's our two rules. All right, so let's do that. Let's take that 1/4 to the outside. And now derivative with respect to x of tangent inverse x over 2 squared. Now derivative of a constant 0, so we'll wipe that out. All right, so now let's bring the 2 down. So I have 1/4 times 2 tangent inverse x over 2 times, and then we decrease the exponent by 1, so 2 minus 1 is 1. Now times the derivative of what's on the inside, which the inside now is derivative of tangent inverse x over 2. You should know from your trig days that theta equals tangent inverse x over 2. So if I'm taking the derivative of theta, or derivative of tangent inverse x over 2, which I'm trying to do here, that's the derivative of theta. Well, this implies that tangent theta equals x over 2. If I use the chain rule here, I can end up with a d theta. So the derivative of tangent is secant squared theta, chain rule, there's my inside function, now d theta. That equals 1/2 dx, right? So 1/2. So d theta equals 1 over 2 secant squared theta, and that is 1 over 2 times cosine squared theta. This looks bad. So it's 1/2 times that, and that's d theta. All right, what does that triangle look like? Sometimes you have to have an imagination to know that's a right triangle. All right, so tangent, opposite over adjacent, is x over 2. This side then would be 2 squared, which is 4, plus that side squared, which is x squared, and the square root of that. Okay? Oh, that has some promise because we have that term up here in the denominator. So d theta equals 1/2 times cosine, which is adjacent over hypotenuse, 2 over square root of 4 plus x squared, but that's squared, okay? So that equals 4 over this 1/2 out here. And the square root of 4 plus x squared squared, radical sign drops away, 4 plus x squared. So 4 over 2 is 2. So I have 2 over 4 plus x squared. That is d theta. So that's the derivative of this inside function here. So that's 2 over 4 plus x squared. All right, how are we going to reduce this? We have 2 times 2 over 4. So that gives me 4 over 4 is 1. So those cancel. I'm left with tangent inverse x over 2 divided by 4 plus x squared. And that was exactly what we started with. So it's telling me then that this answer is correct. All right, guys. Hopefully that what we use, chain rule and constant multiple rule. So actually there's a video I have out there. It has the 9 tools for understanding derivatives. So you need to master those 9 tools, okay? All right, that's all for now. Keep studying together. Let's build a better tomorrow through math, and we'll talk to you next time. Thanks.